Hello everyone, welcome to today's class. As you know, we have started the area of mathematics called geometry. We have done a lot already on geometry, but today we are going to look at shape generally. We have discussed angles, so if you are here to watch that video, please go and watch that video on angles and theorems of angles. Now, today, we are going to look at shape. So before I start, or before we start picking the shape one by one, let us look at the tree diagram of shape. Shape in mathematics are divided into two. The plane shape, which is two-dimensional, and the solid shape, which is what? Three-dimensional. Though our focus today is going to be on plane shape, but we also have to highlight all those other things that's under the three-dimensional shape. Now, under plane shape, we have okay. So these are a kind of a tree diagram for shapes. Okay, I try as much as I can to see if I can be able to capture all the shapes that we need to discuss. Okay, so these are all the shapes that we need to discuss under this particular topic. Now, let me go over it so that you can be able to get what I'm trying to say. Now, under shape, we have the 2D, which is the plane shape, and the 3D, which is the what? Solid shape. Now let's come to the plane shape. Okay, let me discuss the solid shape first. Under solid shape, we have the prism, we have the pyramid, and we have the sphere. When we come to this topic, I'm going to talk about them again. Okay, but briefly, we have the prism. Under prism, we have cube, cuboid, cylinder, triangular base prism, and others. Okay, then under pyramid, we have the cone, we have the square base, we have the rectangular base, we have the triangular base, etc. Then we now have sphere. So all these belongs to 3D. We are going to come to solid shapes, okay, which is the 3D, and we'll talk about each of these shapes you are seeing here. Now, coming to the uh, plane shape, we have the polygons and circle. Now, what are the polygons? The polygons are all those shapes that we get with a straight line. So whenever you draw a straight line, join together to have an enclosure is going to give you a polygon. Okay, so a polygon, just like when you draw your triangle, you use a straight line meeting together to form your triangle. Okay, whether it's a regular polygon or irregular polygon, they are all under polygons. Now we have a circle. Circle, of course, we know a circle which we use a curve to go around and meet. Okay, have the same distance from the center, which is called radius. So we are going to still come to the circle to discuss circle. Now, under polygon, we have triangle, we have quadrilaterals, and we have other polygon. Now, if you look at what I put under polygon, you will notice that it is based on the side. Triangle has 3 sides, quadrilaterals has 4 sides, then other polygons like the pentagon, like the hexagon, like the heptagon, etc. So they are under other polygons. Okay, and there's no space for me to list them out. I would have listed at least few of them so that you can be able to see what is under the other polygons. Now, coming to triangle, we have different kind of triangle, but before you talk about types of triangle, triangle is being based or being classified based on the angles, the nature of the angles it has, or based on the side that it has. Now, when you want to call the types of triangle based on the angles that it has, we have the acute triangle, we have the right triangle, we have the obtuse triangle. Okay. Now, when you want to classify triangle based on the nature of the side, we have the equilateral, we have the isosceles, and we have the scaling triangle. Okay. Now, coming to quadrilaterals, we have basically we have two types of quadrilaterals. It's either a parallelogram and non-parallelogram. Yes, there's always a confusion here that why do we have all these under a parallelogram, and we also have a shape that we call a parallelogram. So I feel that maybe this one don't have a special name, so we leave it as a parallelogram. Okay, so we have a square is a parallelogram, we have a rectangle is a parallelogram, we have a rhombus is a parallelogram, then we now have a parallelogram. Then we now have non-parallelograms. Okay, under non-parallelograms we have kite and we have what? Trapezium. All these shapes you are seeing here, we are going to take care of them one after the other. Okay, so we are going to start with the quadrilaterals. Under quadrilaterals, we are going to start with the parallelogram. We're going to discuss this, then we'll now come and discuss this. Okay, then we'll come to triangle. When we are done with triangle, we come to circle. When we are done with circle, we discuss a little on other polygons. Then when we are done with that, we now come to solid shapes, starting with the prism, the pyramid, and the sphere. So I will encourage you to work with me in this class on geometry. This is not only thing on geometry. Geometry has a lot, so this is just part of it. Okay, so we are going to take it one step at a time. So for the meantime, we are going to start with what? A quadrilateral. So we are starting with a quadrilateral. A quadrilateral is a plane shape with four sides. So any plane shape that you know that has four sides is a what? A quadrilateral. Now we are going to talk about the properties of these shapes. Okay, starting with remember I talked about a quadrilateral being either a parallelogram or a non-parallelogram. Now, what are the properties of a quadrilateral? What makes a shape a quadrilateral? So we'll talk about the properties. So this is the properties of a quadrilaterals. A quadrilateral has four sides. Okay, so that means it will have four sides. A quadrilateral has four vertices. Vertices is any point that two or more lines meet. Okay, that's a vertex. So the singular form of vertices is vertex, then the plural form is vertices. Okay, it has four interior angles that sum to 360. So what that thing means is that the total angle, the total interior angle of a quadrilateral is equals to 360 degrees. Okay, now that we are done with the properties of quadrilaterals, so this is the general properties of all quadrilaterals. So long as a shape is a quadrilateral, it will have these three properties. Okay, so we are going to look at the parallelograms and the non-parallelogram, starting with a parallelogram. Okay, because a parallelogram and a non-parallelogram are two classification of a quadrilateral. Okay, so let us look at parallelogram first. Now, parallelogram. A parallelogram is a shape that the two opposite sides are parallel. So long as the two opposite sides are parallel, it's a parallelogram. Okay. Now we have shapes that are under parallelograms. But before that, let us look at the properties of parallelogram. What are the things that we are likely to see in a shape and we say that, oh, this shape is a parallelogram? So let us look at the properties. So a parallelogram is a quadrilateral. So you can see that a parallelogram is also a quadrilateral. Okay, that means every parallelogram will possess the properties of a quadrilateral. So a parallelogram is a quadrilateral whose opposite sides are parallel. So any shape that the opposite sides are parallel is a parallelogram. In our previous video on geometry, I have discussed what we mean by a parallel lines. Okay, two lines that the distance between them are always equal at every point, meaning that they cannot meet at any point. Okay, they keep moving at a particular distance from each other. Okay, that's a parallel line. So what are the properties of a parallelogram? A parallelogram will possess all the properties of a quadrilateral plus its own properties. So what are the properties, especially for parallelograms. So remember, a parallelogram is also a quadrilateral. Okay, that means it has all the properties of a quadrilateral, then it now has its own special properties. All parallelograms, opposite sides are what? Parallel. The opposite angles are equal. Okay. The number three is that the diagonal bisect each other. Okay. The diagonal cut each other into two equal parts. That's what that means. Then the adjacent angles are supplementary. Now, what we mean by adjacent angle, let's say, for example, I have something like this. These two angles are adjacent to each other. Okay. So the two angles there, they sum to what? 180. That's the meaning of supplementary angle. So let us now look at all the shapes under parallelogram and now see if they have their own properties, okay, that is unique for each of them, then including the ones that we have discussed so far. So the first parallelogram we are going to look at is a square. Now, apart from properties of a quadrilateral and properties of a parallelogram that a square will also possess because it's a parallelogram, what are other properties that a square can also possess? So let us explain these properties of a square. A square has four lines of symmetry. Now, what do we mean by line of symmetry? Wherever you can fold a shape and it will come out the same uh, shape without coming out, extra things coming out, it simply means that that point or that line is a line of symmetry. Now, yes, some people will say that it has two lines of symmetry, yes, but it actually has four lines of symmetry because the diagonals are actually what? Symmetric. Because when you fold, this is a diagonal. When you fold this square into two like this, you are actually going to have just one shape that you'll be seeing. Okay, and because of that, it's symmetric. Okay, if you cut here, the angle, what you have here is what you have here, what you have here is what you have here. So it's going to give you the same shape. Okay, so we can say that it has what? Four lines of what? Symmetry. Now, all angles are equal. So you can see here is 90 degrees, here is 90 degrees, here is 90 degrees, and here is also what? 90 degrees. So they are all 90 degrees. Okay, it has four angles. It has four sides. Okay, all angles are equal and all sides are equal. So you can see the indication that all sides are what? Equal. Now it has two diagonals, so you can cut this way and you can actually cut this way. Okay, so that's the two diagonals. Then each diagonal are perpendicular bisector of each other. What does that mean? It simply means that when you take this, when you have the diagonal, it will meet at this point. Okay, now what does it mean? What does it mean by perpendicular bisector? It simply means that it will form angle 90 at that point. So that means this line is perpendicular bisector of this line. Okay, so for a square we have that property. Okay, now you can see that square has a lot of properties. Now when you include the three properties of a quadrilateral and include the four properties of a parallelogram, a square should have up to 9 properties. Okay, so if you can still look at for more, you can still see more properties of a square. A square is the shape that has the most properties we can think of. Okay, you can even say that it has 4 vertices. Okay, that's one of the properties of a quadrilateral. So we have total of 9. 5 is unique for square. Then since square is a parallelogram, it also possesses the 4 properties of a parallelogram. And since square is also a quadrilateral, it also possesses the 3 properties of a quadrilateral. Okay, so the next one we are going to look at is a rectangle. So we're going to look at rectangle next. Okay, so this a rectangle. Okay, so a rectangle has two lines of symmetry. Now, this is where you will now see that a diagonal in a square is actually a line of symmetry. Let's take a rectangle. When you have a rectangle and you fold this rectangle this way, okay, when you fold this rectangle, when you fold it down, you are likely to see something like this. This one here will come here and give you something like this. Okay, so when you fold it, this is what you are going to see. So you can see that they are not identical. You can see that this one comes out here, this one comes out here. They are not identical. But when it's a square and you cut from here and you fold it, it's actually going to lap. This is what you're going to have. So that's why the diagonal of a rectangle is not a line of symmetry, but the diagonal of a square is a line of symmetry. Okay, so I believe I have explained that. Now, it has two lines of symmetry. Where are the lines of symmetry? When you cut from here and when you cut from here, you are going to have identical shape. Okay, all angles are equal, of course, 90, 90, 90, 90. It has two diagonals. Okay, it has two diagonals. I have shown you that there. Each interior, yes, this property also is part of the properties of a square. So you can see that a square has a whole lot of properties. So each interior angle is 90. So here is 90, here is 90, here is 90. A square actually has a whole lot. Okay, you can look at the shape again and bring out more properties for the square. So these are the properties of a rectangle. So this rhombus, okay, a rhombus is almost like a square. The only difference between a rhombus and a square is that a square, all angles are equal and they are equal to 90 degrees, but a rhombus, they are not equal. You can see that this part, the opposite angles are equal, which is a general property of a parallelogram. Okay, so it has four lines of symmetry. All sides are equal. It has two diagonals, and the diagonals are perpendicular bisector of each other. Okay, I think I've explained these four lines of symmetry. When you cut it from here and fold it, it will give you the same shape. When you cut it from here and fold it, it will give you the same shape. When you cut it from here and fold it, it will give you the same shape. When you cut it from here and fold it, it will give you the same shape. So that's why it has four lines of symmetry. Remember, each of these parallelogram possess extra 7 properties. 3 from being a quadrilateral and 4 for being a parallelogram. Okay, so like the square that has about 5 or 6, by the time you add the 7, you have total of 13 properties. The rectangle that has 4 or 5, if you add the 7, it will have up to 12 or 11 properties. Okay, so these properties of rhombus. Now let us look at the one that we call a parallelogram. Okay, a parallelogram is just like a rhombus. It's just the only difference between a parallelogram and a rhombus is that the sides are not equal. Okay, the sides are not equal. So that's just the only difference. Okay, so this is what we call a parallelogram. The particular shape we call parallelogram, though all of them belongs to the parallelogram of a type of shape. Okay, so this one don't have much properties. It also has the properties of the general parallelogram and also has the property of a quadrilateral. Okay, apart from all those properties, these are the few properties that you can bring out from a parallelogram. Let us move to other shapes that are not parallelograms. Okay, we call them non-parallelogram. Just the way we have discussed the parallelogram, okay, let us look at non-parallelograms. Okay, the opposite side of a non-parallelogram don't necessarily need to be parallel, or you might have two that are parallel, but the other one will not be parallel. Okay, unlike the parallelogram that all the opposite side, okay, are parallel. Also, the opposite angles of a non-parallelograms are not necessarily equal. I have a reason of saying not necessarily because you might just have two that are equal, but the other ones will not be equal. Of course, we have four angles as equilaterals. Two might be equal, two facing each other might be equal, but the other two might not be equal. Okay. Now, the first shape under non-parallelogram is a kite. Now we have listed the properties of a kite. Remember, a kite being a quadrilateral, we also possess the properties of a quadrilateral. So all the three properties of a quadrilateral are also properties of a kite. So you can include it to the one that we have listed here already. So let us look at the properties and look at the shape. It has one line of symmetry. So there's only one line by which you can cut and you fold it and have the same shape. Okay, so that's one line of symmetry. It has two diagonals. So this line of symmetry is also a diagonal, and the other one is also what? A diagonal. And the diagonal are perpendicular bisector of each other. So here they are going to form 90 degrees. So that's why we say that the diagonals are perpendicular bisector of each other. Then the adjacent sides of a kite are equal. This place is equal to this place and this place is equal to this place, because the opposite side is like this. So you can see that they are not equal. This place and this place are opposite, but they are not equal. But the adjacent side are what? Equal. So these are properties of a kite. So let us look at properties of a trapezium. Trapezium can be like this, can also be of this form. So you can see a trapezium is a special kind of shape. Okay, so which you have this and you have this. So it has two diagonals, of course. You can always have it like this. Okay, so the bases of the trapezium are parallel to each other. So you can see that this line are what? Parallel. This line and this line are what? Parallel. Okay, so we can say that all the opposite sides are parallel, because you can see that this place and this place are not parallel, and this place and this place are not parallel. Then, being a quadrilateral, it also possesses all other three properties of a quadrilateral. Okay, so this is where we are going to end the class on properties of quadrilaterals. Okay, in our next class we are going to deal with properties of triangles. So we are going to look at each triangle and look at its unique property. Remember, a triangle is being classified based on the angle and based on the side. So we are going to look at the general property of a triangle and the unique property of each type of triangle. Okay, so please do well to share our video, and if you are yet to subscribe, please join the family and subscribe to our channel. See you in the next class. Thank you very much.